Right. Hello. My name is Ardasher, and this is Ardasher and a student of. This is my final project. It's deep reinforcement learning for U.S. housing market allocation. The goal of this project was to see whether reinforcement learning can be used to make sequential real estate capital allocation decisions across U.S. metro housing. So instead of predicting the price of one house like Zillow does already, I asked the question is like, given current housing market conditions, which metro or city should capital be, or money be allocated to each month? And I felt that was a pretty pressing issue, and kind of for big real estate companies. That's why I chose this topic. Um, so in terms of data, I used the Zillow rent and home value. The data sets ZHVI and ZORI, as well as the Redfin metro market data for things like supply, demand, and liquidity signals, which was just market conditions, essentially. Um, then, yeah, I ended up picking 10 metro areas, just like some big cities to focus on. And the test split was like 2016 to 2022 for training and 23 to 25 for testing. So it's kind of like simulating real conditions if you instead train on everything up to today, and then your actual deployment would be like current and future markets. Um, all right, so getting to the data pre-processing. In pre-processing, I merged the Zillow and Redfin data into a single Metro month panel. I engineered features like 1, 3, and 12-month home value returns, rent growth, inventory growth, home sold growth, new listings growth, a bunch of others. I also handled the missing values and standardized features, basically combining all the data sets together and creating one clean data set that the RL algorithm can later work with. Um, Here's some examples of the cleaned up data. So then the RL environment itself, I built a custom RL environment. So the state is a flattened representation of all metro markets a current month plus the model's current holding. The action space is discrete. It has action zero means hold cash, and the remaining actions are like one per city or metro. And their word is a simplified real estate return proxy. So the next month home value appreciation plus a small rent yield proxy minus the switching cost if if the model ends up choosing to switch markets. Right, then onto the algorithms. Um, the with the first algorithm, well, I compared two algorithms. One was the reinforce, and the others are Actor-Critic. Reinforce is a basic policy gradient method. It learns directly which actions should become more likely when they lead to higher returns. It's pretty straightforward also in our textbooks. Same with Actor-Critic also in our textbook. It separates the system into an actor, which chooses actions, and then a critic, which critiques the actions. And well, we'll analyze the results later. I also, I mean, you see some basic, like, it was 250 episodes, very quick training, a few seconds. Um, so, yeah, you can see some baselines, I think. Well, first, I guess these two are compared. And as you can see, the Actor-Critic kind of has some high episode returns, and then it settles down on one market or metro, while Reinforce is kind of just all over the place and ends up underperforming, as we'll see later as well. Um, for baselines, I chose two. The first one was a momentum baseline, which is just choose the metro with the strongest recent 3 month home value momentum, which like the best performing metro in the past 3 months, and then ended up actually doing pretty well. And the cash baseline, which is pretty objectively just like a floor to have. So then, yeah. So onto the results section. In the best run out of the three samples, Reinforce had about 0.05 total reward. Actor-Critic had about like 0.3. Momentum had selling a little less, like 0.27, and cash baseline obviously is 0, as you can see. So the main result kind of from this is that the actor-critic model converged to Chicago for the full test period, which is awesome because we are basically in Chicago. Um, they did suggest that the reward function, Chicago, under the reward function, Chicago dominates the learned opportunity set. Um, and all right, then yeah, I guess conclusion of okay. Conclusion, I guess overall, let's say this project shows that the reinforcement, um, reinforcement learning can turn housing market um, data into something like a sequential market allocation problem, and it's more than a prediction model, like the ones that are currently available, and there's certainly some potential there. The main limitation, I'd say, is that this is a simplified metro level proof of concept. The training period isn't awfully long. It also doesn't include really high level market conditions like interest rates, taxes, financing, and yeah, I suppose the final takeaway is that the Actor-Critic was the strongest method for the sequential real estate allocation task, and it outperformed the baselines. So yeah, that are pretty alright for itself. So thank you very much, and that's it.